Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on the podcast we like to call Space Nuts. That's because we're nutty as fruitcakes. I'm talking about me. My name's Andrew Dunkley, your host, and with me as always, Fred Watson from the Australian Astronomical Observatory. Hello, Fred.
Hello, Andrew. Yes, fruitcakes are a pretty good analogy, really. I sometimes get called a fruitcake, and that means I'm nutty, I guess.
Yeah, well, yeah, it goes that way. I couldn't think of anything more clever this time of the day.
No.
But it could be any time of the day that people are listening. So we can't say good morning, we can't say good afternoon, we can't say good evening. So we just
got to say good day.
Yeah, we can do that. We can definitely do that anytime. Yep. Now, today, Fred, we're talking planets. The thing about these planets in particular is that they are rotating at perfect musical intervals, which I find astounding. It's got to be a coincidence, but we'll find out more about that. And your organisation, the AAO, has announced a river of stars, which sounds rather fascinating. And we'll finish off today by looking at plans to use a UK satellite to make movies in space. It had to happen one day. It had to. And here it is. But first, Fred, let's look at these musical planets. This sounds rather intriguing.
It's an intriguing story on many levels, Andrew. Not least is the fact that this is a citizen science story, because the discovery has been made by non-scientific people who are working at home and participating in citizen science ventures. In particular, this one is a project called Zooniverse, which is a major online platform for doing crowdsourced research. So what the citizen scientists did was receive downloads of data from the Kepler spacecraft, which you and I have talked about many times. Mm-hmm. A spacecraft actually launched back in, I think, 2009 or something, might even have been before that, specifically to look for planets around other stars. And what it does is it stares at a patch of space or a patch of the sky, and records basically continuously the light of something like 100,000 stars. It's now on the second tranche of the mission, so that might be a different number, but something of that order, 100,000 stars. And what it's looking for is dips in the brightness of those stars as their planets pass in front of them. And so far, something like, it's about 2,500 or 3,000 newly discovered planetary systems have emerged from that project. So a fantastic project. But why do you want to involve citizen science? Well, the thing is that you can analyze these data with a computer, of course, but computers are not that good at picking out regular dips. Sometimes the data are very, very noisy. So you've got dots all over the place. And what you're looking for is a series of brightness measurements, which are slightly lower than the brightness measurements of the star when it's unobscured by its intervening planet. So the noise in the information is something that the computers are not that good at picking out or getting through, but humans are. And so that's why something like 50,000 data sets have been made available on the Zooniverse project, and people are looking through them, looking for something that to the human eye looks like a dip in the brightness of the star, and then checking that with the project team. And indeed, that's exactly what's happened here. And the outcome is that this is a system with 5 planets in it, a solar system, 5 planets, big, possibly bigger, because there's a hint of a 6th as well in the data, but that has not yet been confirmed. It's unusual. It's much smaller than our solar system. The furthest of those 5 planets orbits its parent star in about 12 days.
Wow.
And the others are much quicker because they're further in.
That is a really concentrated block of
it is,
planets, isn't it?
It is. I think this is a red dwarf star. It's not a sun-like star because they'd all be fried if it was sunlight. But nevertheless, these are genuine planets. They're actually rather bigger than the Earth. They range in size between 1.6 and 3.3 diameters of the Earth. But as you said, the really striking feature of them is the relationship between the length of the orbits of these planets, and as you said, it's got links with musical theory. So what's happening when you look at the planets? It turns out that there are what we call resonances in the orbits, and we talk about resonances as ratios. And so the resonance that's in this solar system is something we call a 3-to-2 ratio. So what it means is that every one of those planets goes round, it makes 3 circuits of its parent star in the same time that it takes the next one out to make 2. So one planet goes round 3 times, the next one out in exactly the same time interval goes round twice. And the same is true progressively out from the parent star itself. It's what's called a resonance chain.
So 3 and 2, 3 and 2, 3 and 2.
Yeah, that's right. Yeah.
Wow.
And so it's actually not a coincidence. This is something that you kind of expect to happen because it's just about the gravitational interplay between these planets. We see examples actually in the solar system. Neptune and Pluto are in resonance. I can't remember the exact resonance. I think it might be 2 to 3, but there's a similar sort of thing. And if you think about it, you can sort of understand how it's happening because...
Well, that's the obvious question. I mean, is this just a coincidence or is it something that can be defined in science or something like that?
Yeah, that's right. So it's the latter. So what happens is that the gravitational interplay between, say, a pair of planets means that that the gravity of one affects the movement of the other, and that happens for both of them. And so when you've got this 3-to-2 resonance, which is the sort of end product of these gravitational interactions, it means that every 3 circuits of one star, the other star is going to be in the same position, if you see what I mean. So every 3 circuits of an inner star, the outer star will be in the same position. Every 2 circuits of the outer star, the inner star will be in the same position. And that's the sort of the way the gravitational lock-in works. And I think this is the first time, though, that we've seen 5 planets, all of them having this chain of resonances. And as I said, there's evidence for a 6th one, which would also be in resonance.
So that would be guaranteed. Judging by what's happening around this star, if there is a 6th planet, it would definitely be in resonance as well.
Well, what they've done, they've sort of got tentative evidence for a 6th star, which has an orbit of 42 days. Now, that's much more than the outermost one that we know already. And what is being suggested is that 6th star is also part of the resonance chain, but there are two empty spots in between. There are 2 gaps in the chain.
Oh, okay.
One at 19 days and one at 27 days. And so there may well be planets in those spots as well. So it could go up to 8 planets, this solar system.
That's fascinating.
If we discover those 2.
Gee, that
it's
would be
amazing stuff.
Yeah, and I suppose it brings into play that if they're rotating like that and it's very regular and quite precise, there'd be times when there's common planetary alignments. Would that be true?
Yes, that's right. Exactly. So you will get these alignments, and there may well be an instant when they all line up, because that's the way the resonances work. Quite fascinating.
Because in our solar system, that's a rare event because
it is. Yeah.
So distant.
I think it's 2030. I think. No, 2040. I think is the next. Is the next major alignment when all 5 naked eye planets are in the same part of the sky. I think it's 2040. Just going back, though, to something we mentioned right at the beginning, what's the connection with music?
Yeah.
And it's the fact that musical notes are related in a similar way. And so the interval between do and so, wait a minute, do, re, mi, fa, so, there you go,
Yep.
do and so. First, the first two notes of Twinkle, Twinkle, Little Star are what's called a fifth. Twinkle, twinkle, it's do to so.
Yep.
And that is a musical interval called a fifth. And the frequencies of the sounds are in a 3-to-2 relationship. That's why it's a musical phenomenon as well. So the resonance effect extends to music. Forgive my singing, everybody. That's why we're called Space Nuts, because we attempt the impossible. Anyway,
and we do it very poorly. Yes,
we do it very poorly. That's right. But there's music in the spheres as well as the planetary discoveries.
Yeah, quite remarkable, and and it just keeps amazing me that we're finding all these unusual and amazing phenomena. You just got to wonder what else is out there, which is what your job's all about, Fred. Basically,
it is. It is. That's right.
All right, you're listening to
a dream job.
Hey.
It's a dream job.
Of course it is, yeah.
Yeah.
And if we can inspire others to follow in your footsteps, we're doing our job too. This is Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by Tech Radar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree, and governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
3, 2, 1.
Space Nuts.
Okay, Fred, now we're going to talk about your organisation, the AAO, the Australian Astronomical Observatory, because your facility, or whatever you want to call it, has just released data about a river of stars. I've heard of a river of dreams, and I've heard of a few other variations on the theme, but a river of stars sounds delightful.
Yeah, they are. Technically, we call them stellar streams, which are streams of stars. So the idea is that out there in space, there are stars which are kind of moving in concert with one another. They're moving together, although sometimes they're spread out over quite large distances. We call them stellar streams. They've been known, or the idea has been known, since the middle of the 20th century. But we believe that what's called the halo of our galaxy, and this is a kind of spherical ball of stars which sits around and envelops the the disk of our galaxy. We usually think of our galaxy as having this disk of stars and gas and dust, which has these beautiful spiral arms in it, something like 400 billion stars in the galaxy. But another component of the galaxy is what's called the halo. The halo is much fainter. We see them in other galaxies, so that we know they exist. A halo of I don't know, probably a few billion stars, maybe a few tens of billion stars, which form a sphere almost, a big spherical blob of stars around the disk of the galaxy. Now, we believe that halo actually grew, and in fact the whole galaxy has probably grown by gobbling up other smaller galaxies. And I've worked on projects which have been designed to look for the evidence of some of those smaller galaxies, the sort of partially digested remains of them, if I can put it that way. And we see these as streams of stars in the halo. Why are they streams? Because what happens is if you've got a little galaxy that strays into the gravitational pull of our own galaxy, which is a big one, what happens is that this little galaxy is following an orbit around at the center of our Milky Way galaxy, but the gravitational pull spreads the stars out along that orbit. So the stars of this poor little galaxy that's being gobbled up, its stars are pulled both ahead of it and behind it as it's dragged out into what really amounts to a line of stars streaming through space. And that's what we call the star streams. Why are they important to look for? Because it tells us about the way our galaxy has been put together. So going back a little bit, one of the projects I've worked on, something called RAVE, the Radial Velocity Experiment, which I think we talked about quite a lot in the the period about a decade ago.
Yeah.
One of the first discoveries that was made from that was a stream of stars in the constellation of Aquarius. So it was called the Stream of Aquarius. In fact,
that's rather apt. Aquarius being the water carrier.
The water carrier, yeah, that's right. It's very, very, very appropriate. But other projects have also looked for these star streams, and in particular now there's been a release of data from something called the Dark Energy Survey. Now, that's a survey being carried out, actually not with our telescope, but with a very similar one in Chile. It's called the Victor Blanco Telescope. It looks a lot like the Anglo-Australian telescope in Coonabarabran, roughly the same size, a 4-meter diameter mirror. And they have a camera on that is looking very, very deep into space. And it's actually looking principally at distant galaxies. And that's so that we can work out some of the important attributes of the universe as a whole, and in particular something called dark energy, which we think is a property of space itself. So that's what that project was designed to do. But incidentally, it also, as well as seeing galaxies, at the limits of our detectability, way, way in the depths of the universe, it also sees nearby things too. And in fact, it sees the stars of our galactic halo. And so an atlas has now been produced of the stars in the halo of our galaxy, these faint stars that basically, they don't really interfere with the view of the distant galaxies beyond, but they are there in the foreground. So we've got a catalogue of these stars, and it's that has produced the evidence of, I think, 11 new streams of stars. It's really quite a dramatic improvement. 11 new stellar streams around our own Milky Way galaxy. The reason why this is an AAO press release from our own organisation is that one of the key players in this, Kyler Kuhn, Dr. Kyler Kuhn, is one of our staff members. He's an important component of the Dark Energy Survey. So these streams of stars have now been named. And that's where it gets doubly interesting, Andrew, because it's not often that you can engage the public in naming celestial objects. There are very strict protocols about naming stars and things of that sort, all dictated by that august body known as the International Astronomical Union, the IAU. But Kyler and his colleagues have actually gone out with public talks and things of that sort to ask for suggestions for the names of these stellar streams. And what they've looked for is the traditional names for things like rivers and streams given by various indigenous peoples who are associated with the project, and in particular indigenous names from Chile, where the telescope is, and Australia, where we are. So there's something like, I think something like 6 of them now have South American names, Chilean names, but 2 of them have got Aboriginal names because of the Australian connection.
Yeah.
I'm going to blow my own trumpet here and tell you that I actually suggested one of them because it's a name that's very familiar to us at the Anglo-Australian Telescope. That is Wambalong, Wambelong, and it means crazy water in Kamilaroi, the language of the indigenous people around the telescope.
A couple of years ago, it was a crazy fire because
it was a crazy fire.
A
That's
huge
exactly
fire
right.
that almost threatened to destroy your entire facility there. And it started in that particular creek, and that's why it was called the Wambalong Fire. And
that's exactly right.
It destroyed 90%, about 90% of the national park that surrounds you there. It was a horrific fire. The only good thing that came out of it was that no people died as a result.
Yeah.
But lots of property losses, lots of stock and native animal losses. It was horrific.
That's right.
So it's good that the name can be turned around for a positive thing.
Indeed, that's correct. And that was one of the reasons that I had in mind when I said, why don't you call it Wambalong? And that then went to a public vote, and the people liked it. Just as an aside there regarding the fire, it's only a few days ago, Andrew, as we're speaking, that we commemorated the 5th anniversary of that fire. It took place on the 13th of January 2013, 5 years ago.
Gee, that's gone fast. Yeah.
It's gone fast, hasn't it? And of course, the landscape still bears the scars of it. The observatory, as you correctly said, was under serious threat, but we came through that thanks largely to the water bombing efforts of the Rural Fire Service.
They saved my radio transmitters too. I was working for a radio station that had transmitters on the next mountain to yours,
yes,
and
that's right.
They were under threat. We thought we'd lose them, but they saved them as well. But
so remarkable stuff. So it's great that that name of Wambalong is actually being now preserved in the heavens. There is a stellar stream whose official name is Wambalong, and the other Aboriginal name actually comes from the Darug people not very far from where our headquarters are in Sydney, in the Lane Cove region. It's actually the name for the Lane Cove River in that language. It is Turranburra, and so that is the other star stream that is now being discovered, the 2 with Aboriginal names. It's a very nice story.
It is,
and
lovely.
I'm delighted that they've commemorated these things in the heavens in that way.
And we're naming the streams after streams, which I like as well.
Yes, that's right. Yeah. So the same's true with the Chilean names. There's various meanings like quiet water and crossing rivers and sacred water. Their names too are connected with water.
Yeah, well, one of theirs is jumping out at me because I'm thinking it's probably not quiet water if it's named Turbio.
Yeah, that's right. Actually, that's the Spanish name, Turbio. Okay. Probably means it's pretty treacherous.
Yes, indeed. And one final thought. Now that all these star streams have been discovered, it sounds like that they are a fairly common phenomenon.
That's correct. We think that that the halo itself the galactic halo has been put together by basically all these gobbled up mini galaxies which have formed stellar streams. And in fact, back in the early days of the RAVE project, the one I mentioned earlier that I was working on, in about 2003, some of my colleagues produced a simulation of the halo of our galaxy based on it having gobbled up 100 mini galaxies. So there are 100 star streams in there, and actually what you get is something that looks a lot like what we find. And it's only now, though, that we've got the sensitivity and instruments to be able to unravel those individual star streams and see them kind of mapped out on the sky, which is, I think, very exciting.
Indeed it is. Well done, Fred, and to you and all your colleagues and the Chileans as well for finding these things. And I love the way you've put the names together. It's fantastic. You're listening to Space Nuts as we stream into your place with Fred Watson and Andrew Dunkley.
0G, and I feel fine.
Space Nuts.
Finally, Fred, we're going to talk about making movies. Now, I think you and I discussed, or I might have mentioned not so long ago, that the day would come when we would make a motion picture in space, rather than doing it with CGI or, flying people at very high speed vertically downwards to get the zero-G effect. We're now looking at making movies in space using a British satellite. Now, I'm thinking it'll be a fairly rudimentary start, but the day will come when actors are up there doing it too. But what's going on here?
Yeah, this is an interesting story, and you're quite right. The day will come when there are actors up there. It's almost the case now, because a lot of these guys on the International Space Station, and girls, of course, too, are very at ease in front of a camera, and we've seen all kinds of tricks and things. But this is something a little bit different. This is a spacecraft which is going to be downward pointing. And you might say, well, what's new about that? We have, downward pointing surveillance and environmental spacecraft up there all the time, looking at the surface of the Earth and monitoring it. And the difference here is that this will not be successions of just still images, which is what we have now. And you've only to think of things like Google Earth, where you're looking down on the surface of our planet. That's the kind of still image that we are familiar with. What these people are talking about, and it's actually a British company who wants to do this, is to make video movies from orbit, looking downwards, and it's actually full color, high definition video. And the difference is that if you do that, you can see things happening in real time. For example, if you had a spacecraft, a satellite, overflying a city, and you've got real-time video coming back from that, then you're going to see all the nuances of traffic movement within that city. You're going to see the cars moving. In fact, there is on the BBC website, there's a simulation of what the video footage from this spacecraft will look like. It's not there yet, so it's not. It's actually the demonstrator's gone into orbit, but that's all it's doing is demonstrating the technology. We haven't really seen any results from it yet, but there are simulations, and you can see the value of it just by looking down. You can see the way the traffic's moving and things of that sort. And they're also suggesting that it would be very good for modelling traffic flow, not just on the roads, but also at sea, and maybe in the major ports of the world, to model the flow of shipping around and through these ports. That you could do that if you had examples of footage to show how things are moving from space. And so they are very hopeful that they will be able to launch a constellation of small spacecraft. They're only, they're not quite the nanocubes that we've seen, but they're a little bit bigger than that. But they're planning to launch a constellation of the spacecraft. I think they're going to call it Vivid Eye as the name of the constellation, and it'll provide this high definition, full color video, kind of wherever you want. They'll be at a height of about 500 kilometers. It does mean that you can sort of steer these things almost. If there are trouble spots, if there are things going on in the world, like natural disasters and things like that, where it's going to be valuable to have real-time video, and this is 50 frames a second video, so it's high definition. Yeah, then you can sort of start to see the possible benefits of this technology. I think it's still in its infancy, but Vivid Eye sounds like a very interesting topic to watch, and maybe you and I will talk about it when we start seeing the first video coming back from outer space.
Yeah, I hope so. And I suppose as the technology advances and maybe they put more and more of these things in space, they'll find other uses for them, as you said, looking at natural disaster zones, but maybe search and rescue if they can get better cameras.
Yeah, that's right.
War zones, things like that. I can see military applications, definitely.
Well, they've probably got it already.
They probably have, now that you mention it, yeah. But, I think making movies in space, or at least getting some footage to use in movies from real-time cameras orbiting the planet would, certainly value add to the motion picture industry in a very spectacular way, because they've been basically using either real images that are stills or very basic stuff, or CGI. Although one of the best examples of footage I've ever seen was at the very beginning of the movie Contact. Now, I know it was a CGI production, but where they started by listening to radio signals on the Earth, and then they moved away from the Earth out into deep space, and it was just a magical sequence. If you ever want to look it up, it's really worth it. And it starts the movie in a very good way. But we're talking about using real footage and real pictures.
That's right.
In real time. That's the next big leap for movie kind. All right, Fred, thank you so much. As always, very entertaining and interesting. And congratulations again on your River of Stars.
Thank you. And don't forget the musical notes, do to so.
Yes.
Planets work that way too.
You keep practicing, Fred.
Oh, well, yeah.
Please.
Don't give up your day job. Yes, I know.
And we will catch you again very, very soon.
Sounds great. Thanks, Andrew.
Fred Watson from the Australian Astronomical Observatory. And between he and I, we are the Space Nuts, and you are too. So, you know, I think we'll get a badge. That'll be good. In the meantime, keep listening. Tell your friends. Share us on Facebook and Twitter. Send us your questions or your thoughts or your ideas or your links. We do love to hear from you, and we look forward to catching you again on the next edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.